Hi guys, for today's lesson we're going to be dealing with the gradient of an interval. So first up, what do I mean by this word gradient? So the gradient is the steepness of one of these intervals. And remember, an interval is pretty much just a line between two dots. So important thing to note is that positive gradient suggests an uphill slope from left to right. So this is going uphill. And a negative gradient suggests a downhill slope from left to right. So that's going downhill. Also, if you've got a flat line, that suggests a zero gradient. And if you've got a vertical line, that suggests an undefined gradient. So it's important to remember what sort of gradients are zero and what sort of gradients are undefined. And this pretty much sums up all the different types of lines you can have in terms of their gradient. So the gradient between 2 points can be calculated using, that looks a little bit funny. So I'll just fix that one up. So calculated using the following formula. So the gradient and the symbol for gradient is m. Can be used this formula here. So y2 minus y1, that's considered to be the rise of the gradient. And x2 minus x1, that's considered the run for the gradient, where x1 and y1 and x2 and y2, these are the coordinates of your 2 points. This is considered like a 2-point formula for gradient. You need 2 points to be able to figure out what a gradient is. Okay, so EG1, find the gradient of the interval between these 2 points here. Well, we just jump straight to this sort of formula. Remember that your y's are on top, and the reason is because the rise of your gradient is the difference between the y values. So your y's are on top and your x's are on the bottom. So we've got minus 5 take away 6 on top, and then on the bottom you've got 2 take away negative 3. Notice the double negative here, that's going to make a plus. So it's going to be 2 plus 3 to make this 5. And we get negative 5 take away 6 is negative 11. So we get negative 11 on 5. That is our gradient. Notice it's negative, so that suggests a downhill slope. And you do see that it's a downhill slope here. Okay, so note, gradient can also be described by the angle that the interval makes with the x-axis. So the gradient m, another formula instead of rise over run, is also tan of alpha. And we say that alpha is an angle that is made with the x-axis using your interval. So let's do another example. So determine the gradient of the following interval here. So we've got our interval from this dot to this dot. What is its gradient if we know that the angle that it makes with the x-axis, and notice that the angle made is always to the right of this line. We go from our line, or we go from the x-axis on the right hand side. We're not going to use this angle over here, we're going to use the angle on the right. Now I know that we're given that that's 135 degrees. If we know this angle, we can find the gradient of this line by using this formula right here. So m is equal to tan of alpha. Our alpha changes to our angle, and tan of 135 degrees, you can put that into your calculator, that gives you negative 1. So our gradient is negative 1 in this case. And negative 1 suggests a downhill slope as well. So that's just another formula that you need to take on board. Parallel lines, there are 2 or more lines that have the same gradient. So typically you would have thought of parallel lines as being 2 lines that never touch each other, but in this context, parallel lines have the same gradient. So you can prove whether things are parallel or not based on what their gradients are. Perpendicular lines, so they are 2 lines that intersect at right angles, i.e. the 2 lines with i.e. 2 lines with negative reciprocal gradients. So if you've got 2 lines that intersect at right angles, they're perpendicular, and their gradients are going to multiply to give negative 1. Or the gradients are negative reciprocals of each other. So This is, yeah, so this is the gradient of the first line, that's the gradient of the second line, and they have to multiply to give -1. E.g. 3, so let's practice this. So the interval PQ has a gradient of -3. They give you that gradient. What is the gradient of an interval that is perpendicular to this PQ? So the idea is that the gradient of your PQ is -3. I've given you that. That's the same as -3/1. Hence, the negative reciprocal. What I'm going to do is I'm going to take the negative reciprocal of this gradient. Now, that means I'm going to flip it and I'm going to change the sign. So flipping 3/1 becomes 1/3, and it's negative already, so it's going to become positive 1/3. So that is what I call the negative flipped version, and that is the gradient of that's the gradient of an interval that is perpendicular. And I want you to notice that this and this, they're going to multiply to give -1, which has to be the case. So it's all about the gradients multiplying to give -1 if they are perpendicular. And this diagram kind of shows that. So here I've got my -3/1 gradient. You can see that it's a downhill line, and it's 3/1 as my rise and run. So that's where I'm getting 3/1, this gradient right here. And you can see that the negative reciprocal gradient is 1/3. So that means the rise is 1 and the run is 3. And it's positive, so it's going to be going uphill. And you can see from these two lines that these two gradients are making a right angle with each other. They're perpendicular. So you need to be able to go from a gradient like this and figure out what would be the gradient of the perpendicular line. I hope this helps with the questions. Good luck.